Imagine, if you will, looking up at our celestial neighbor, the moon. For millennia, it has hung there, a silent, unchanging sentinel in the night sky. We've sent probes, walked upon its dusty surface, and collected samples, believing we understood its fundamental nature, a dry, airless, barren world. But what if I told you that this familiar, ancient orb held a secret, a tiny, almost impossible detail that completely upended our understanding? A whisper of something utterly unexpected, something that, by all scientific logic, shouldn't be there at all. Rust. Yes, that reddish-brown flaky substance you find on an old garden tool left out in the rain, or on the hull of a ship long exposed to the sea air. Rust on the moon. It sounds like a premise for a science fiction novel, doesn't it? A playful contradiction, perhaps. Yet the evidence is not only real, but it's beyond dispute, and it presented scientists with one of the most intriguing puzzles of recent times. The story begins with data from India's pioneering Chandrayaan-1 mission. This ambitious lunar orbiter, launched in 2008, carried instruments designed to map the moon's surface and search for water. Among its many discoveries, it provided invaluable information that years later would lead to this astonishing revelation. It was a Hawaiian researcher named Shuai Lee meticulously sifting through this treasure trove of data who showed clear signs of iron oxide, the chemical compound we commonly know as rust, on the lunar surface, particularly at higher latitudes. Now pause for a moment and consider the implications of this finding. Rust, or oxidation, is a chemical process that occurs when iron, or an alloy containing iron, is exposed to oxygen and moisture over an extended period. Think about the conditions necessary here on Earth: a metal surface, the oxygen in our atmosphere, and the ubiquitous presence of water. Then turn your gaze back to the moon. It is an airless vacuum devoid of any significant atmosphere. Water, while now known to exist in trace amounts in shadowed craters, is certainly not abundant enough to drive widespread rusting. So how on Earth, or rather how on the moon, could rust possibly form? Scientists, understandably, were flummoxed. It simply didn't make sense. On top of the glaring lack of oxygen and water, the moon faces another environmental challenge that should, by all accounts, make rust formation even more improbable. Our sun constantly emits a stream of charged particles known as solar winds. These winds carry a relentless barrage of hydrogen atoms directly towards the moon. Hydrogen is known as a reducing agent. It tends to donate electrons, making it even more difficult for iron to oxidize. In fact, solar wind hydrogen should actively prevent rust from forming, not allow it. Rust on the moon should be impossible. And yet, there it was, undeniable, etched into the data from Chandrayaan-1. For a time, this was a truly perplexing mystery, a cosmic anomaly that defied our understanding of both chemistry and the lunar environment. It was a testament to the persistent curiosity of scientists that they continued to search for an explanation, convinced that there had to be a mechanism, however subtle or unexpected, at play. Then came the breakthrough, a beautiful example of how seemingly disparate scientific fields can converge to illuminate a single truth. The answer, it turned out, lay not just with the moon itself, but with our very own planet, and specifically with the shape of its magnetic field. We know that Earth is also constantly whipped by those same solar winds. But unlike the moon, our planet is protected by a powerful magnetic field, which acts like an invisible shield. This shield, however, isn't static. The solar winds squash and distort our planet's magnetic field, pushing it inwards on the side facing the sun, and, more importantly for our story, stretching it backward on the side furthest from the sun. This creates a vast, elongated structure, like a shimmering, invisible tail trailing behind our planet. This cosmic appendage is known as the magnetotail, and it extends an astonishing 240,000 miles, or approximately 385,000 kilometers into space. It's so long, in fact, that it can stretch far beyond the moon's average orbital distance. And this, precisely, is where the moon story takes a fascinating twist. During its monthly orbit around Earth, our moon does something quite remarkable. For about 5 days each month, it dips briefly inside this vast protective magnetotail. For a short, fleeting window, the moon is no longer directly exposed to the brutal, hydrogen-rich solar winds. The Earth, in effect, shields its lunar companion from this relentless bombardment of hydrogen atoms. But that's not all. This magnetotail also plays another crucial role. It carries with it tiny but significant amounts of oxygen that have escaped from Earth's upper atmosphere. Our planet's magnetic field acts like a subtle, almost imperceptible conveyor belt, delivering these precious oxygen ions directly to the lunar surface. So, for just a few days each month, when the moon is nestled within Earth's magnetotail, a truly extraordinary set of circumstances align. The moon is shielded from the hydrogen that would prevent oxidation, and it receives a subtle yet steady supply of oxygen from Earth. For this brief window, the conditions are, miraculously, just right for rust to form. It's an elegant solution to a profound mystery, a testament to the interconnectedness of our solar system. The moon, which we once viewed as an isolated, unchanging rock, is, in fact, subtly influenced by its home planet in ways we are only just beginning to understand. This discovery reminds us that even in the seemingly barren expanse of space, life's essential elements, like oxygen, can travel in unexpected ways, leading to the most improbable of phenomenon. The mystery of rust on the moon is a beautiful narrative of scientific inquiry, from a puzzling observation rooted in meticulous data analysis, to a breakthrough that challenges our assumptions, and finally, to an elegant explanation that reveals a deeper, more profound truth about the cosmos. It's a reminder that the universe is always ready to surprise us, inviting us to look closer, ask bolder questions, and appreciate the subtle dance of forces that shape everything around us. What do you think of this cosmic collaboration, this strange gift from Earth to its moon? Has this discovery changed your perception of our celestial neighbor? Share your thoughts in the comments below, and if you enjoyed this journey into the unexpected, please consider subscribing for more stories from the frontiers of science.